Homework 4, Ionic Compounds. So in homework 4, we're looking at the chemical formula of some ionic compounds. So we're going to need to understand the charges that different atoms form, and we need to understand what polyatomic ions are. So everything in the first column is going to form a +1 charge, and that's because everything in that column has an s1 electron configuration. It's going to get to an octet by losing 1 electron. Second column is going to lose 2. The ones in the middle, we haven't dealt with those ones just yet. Boron would lose 3. Carbon, we're not sure if this column is going to gain 4 or lose 4 to get to an octet. Nitrogen's column all has 5 valence electrons, so they're going to gain 3. Oxygen's column has 6, so they're going to gain 2. And fluorine's column has 7, so they're going to gain 1. And the last column here is not going to gain or lose electrons because it already has a full octet. Those are our noble gases. We also have the polyatomic ions on the screen here. So poly means many. So a polyatomic ion is going to be many atoms, but they behave like one ion. So for example, we could have the chloride ion, -1, that would be a monatomic ion. And we could have carbonate, which is CO3 with a -2 charge. So that would be a polyatomic ion. They're both ions, they have charges, it's just, are we dealing with one atom or are we dealing with several atoms? So first we have sodium and sulfate. So sodium is going to form a +1 charge. Sulfate is a polyatomic ion with the formula SO4 with a -2 charge. So the sum of these charges should add up to 0. So I'm going to take this 2 and bring it over here, and this 1 and bring it down here, and this gives me Na2SO4. There are 2 sodiums, each one is +1, and there's 1 sulfate, which is -2. So when you add those together, you get 0. That's how you know you have the correct formula for an ionic compound. For Fe +3 and Cl -1, I'm going to crisscross my charges here. So this gives me FeCl3. There's 1 iron, that's +3, and each of these chlorines is -1, so this adds up to 0. Next we have copper 2 and nitrate. So copper is one of those elements that we don't know what charge it's going to form. So this 2 is telling you the charge of the copper, not how many. It's telling you that this charge is +2. Nitrate is NO3 with a -1 charge. I'm going to put this guy in parentheses, and then I'm going to cross my charges here. So this leaves me with CuNO3 in parentheses and a 2. So we have copper, that's +2. Each nitrate is -1, so that adds up to 0. And I want to put a parenthesis here because if I didn't, it would look like NO32. I'm trying to say that we have 2 nitrates, so we need that parenthesis there. Here we have Ca+2, and we have a polyatomic ion chromate here. So, or not chromate, rather. We have a polyatomic C2O4. So the charges here are +2 and -2. So when we crisscross the charges, we get a 2 and a 2. So we're going to simplify that to just be 1 to 1. So my formula would just be CaC2O4. Ammonium and nitrite. So ammonium is a polyatomic ion, NH4 with a +1 charge. Nitrite is NO2 minus. So my charges are +1 and -1. So this is already balanced, and my formula is NH4NO2. For aluminum and phosphate, again, we have a +3 and a -3. So if we switch those charges, we got a 3 and a 3. So we would just simplify that to be AlPO4. Next, we have lead-4. So lead is in that same column with carbon where we're not sure if it's going to gain 4 or lose 4. So the charge of that lead has to be given to you. So the charge on this lead is +4, because this Roman numeral means 4. And bromine is going to form a -1 charge. So I can crisscross my charges here, and that's going to give me PbBr4. We have one lead that's +4, and then we have 4 bromines that are each -1. So again, this charge adds up to 0. For calcium +2 and nitrogen -3, we can crisscross those charges, so we get Ca3N2. There are 3 calciums, each one is +2, and there are 2 nitrogens that are each -3, so that gives us a total overall charge of 0. So explain what a polyatomic ion is and give an example. So this means many atoms that behave as one ion, meaning that they have one charge. So if we look at the polyatomic ion nitrate, so nitrate contains a nitrogen and 3 oxygens, but they all behave as one ion. So all of these atoms are stuck together with one charge. Kind of like how Cl-1, this would be a monatomic ion. It has 1 overall charge. So does our polyatomic ion. Many atoms that have 1 overall charge. We want to color code to show our metals, nonmetals, and metalloids. So my metalloids are the ones that are going to be along the staircase on the periodic table. Some people consider aluminum to be a metalloid. It's a very poor metal. And then my nonmetals are going to be all on this side of that staircase. So these would be all of my nonmetals and hydrogen. And then that means that everything else on the periodic table, all of these other guys, these are our metals. And then what type of elements are going to form ionic compounds? So we need a metal and a nonmetal. Remember, metals are going to lose electrons and nonmetals will gain electrons. Or if you have a polyatomic ion, that also tells you that it's ionic.